Welcome to Kindergarten Video on Demand. This video is an overview of Unit 7, using numbers and data to make sense of my world. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 7. In this portion of the video, we will review the AKS and IOAs for Unit 7. The AKS are the overarching academic knowledge and skills that students are expected to master. The IOAs are the indicators of achievement and the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 5 AKS. Under the AKS, you will find the IOAs. At the end of each AKS and IOA, you will see the state coding in parentheses. If you want to look for resources on the Georgia Department of Education website, you will use this state coding. Each AKS and IOA in Unit 7 has been introduced in a previous unit. Unit 7 is an opportunity for our students to bring their learning together and see how we use numbers and data to make sense of our world. The focus of Unit 7 is AKS 5, specifically IOA 5.D. AKS 5 addresses students explaining the concepts of addition, subtraction, and equality to solve real-life problems within 10. We have done previous work with AKS 5 in Unit 5A when we decomposed and composed numbers up to 10, as well as in Unit 5B when the concepts of addition and subtraction were introduced. At this point in the year, students haven't had experiences with the following problem types: join, result unknown, separate, result unknown, part whole, whole unknown, and part whole, both parts unknown. We will continue to work with these problem types in Unit 7 with a focus on IOA 5.D, where we will build fluency within 5. Because we are building fluency, we will introduce part whole, part unknown. This problem type will first be introduced in context to build conceptual understanding, and then as equations and sentence stems, such as 5 is the same as 3 and blank. Part unknown problems will only be done within 5 as students develop fluency. To achieve fluency, students should be able to choose flexibly among methods and strategies to solve mathematical problems accurately and efficiently. Fluency does not lend itself to time tests or speed. Exposure to equations is expected, but mastery of equations is not required. 3 phrases in the process of learning basic facts include counting strategies, reasoning strategies, and phase 3 of mastery. The key to teaching basic facts effectively is to focus on number sense and the development of reasoning strategies. Lessons in Unit 7 will follow the phases for learning basic facts. After lessons have been taught to support reasoning strategies, developing fluency will continue in activating strategies through number talks. We will revisit AKS 7 in this final unit. While this AKS consists of physical and measurable attributes of objects and analyzing graphical displays, our focus in Unit 7 will be on indicator 7.C. The goal is to use mathematics to make sense of the world around them by asking questions that they care about and collecting, gathering, and interpreting data to answer those questions. Students display their data using objects and pictures. Students should be able to use friendly language to explain their data and answer the overall question. AKS 3 was the focus of our previous unit, Unit 6. In this unit, Unit 7, AKS 3 will be revisited in the activating strategies. AKS 3 sets the stage for building a deep understanding of the base 10 number system by composing and decomposing the numbers 11 through 19. Students develop an understanding of teen numbers as a group of 10 ones and some more ones. This foundational understanding will be extended in first grade when students are formally introduced to place value and unitize the 10 ones to a 10. Since kindergarten students do not unitize the 10, base 10 blocks are not used in kindergarten. Our ongoing AKS 6 will continue to be revisited in Unit 7. AKS 6 states that students will explain, extend, and create repeating patterns with a repetition not exceeding 4 and describe patterns involving the passage of time. The study of patterns provides opportunities for students to make connections. These connections help to build a foundational understanding of algebra as it relates to addition and subtraction strategies, the count sequence, and geometric understandings. IOA 6.A states that students will describe a repeating pattern with no more than 4 repetitions or iterations of the core, which is made of shapes or numbers. This can also be extended to a repeating pattern of objects. Once students have identified the repeating pattern, they extend the pattern. Students also create patterns of their own. It is important to know when showing students a pattern to describe and/or extend that the entire core should be created in the repetitions. For example, if the pattern is triangle, square, square, that entire core must be shown at least twice. Before beginning Unit 7, all learning targets for IOA 6.A and 6.B have been introduced. Our work with these IOAs in this unit will allow students to continue to work towards mastery of AKS 6. The final AKS in Unit 7 is AKS 2, which is also an ongoing AKS throughout the year. AKS 2 consists of students rote counting forward to 100 by ones. Starting at 10, students will rote count forward by 10s to 100. This standard requires students to rote count backwards from 20. Students will also count forward within 100 and backward within 20 from any given number. At this point in the year, all parts of this AKS have been introduced. In Unit 7, students will continue to work towards mastery of this AKS. Pacing Guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated. But teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 7. In the box which names the unit, you will see the suggested pacing. For Unit 7, we suggest about 5 weeks. The big ideas, as well as any links we feel would be beneficial for the entire unit, are also included in this box. Next, you will see a list of the AKS and IOAs which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete, representational, abstract progression, or progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this column. The right column provides resources to guide instruction. We will begin our work in Unit 7 with IOAs 5.D, 5.B, and 5.C. Students have experience with adding and subtracting within 10 from Unit 5B. Our focus for Unit 7 is to develop fluency within 5, and we will kick off the unit with a task-based lesson. Since students have experience and should have conceptual understanding of what it means to add and subtract, counting on, counting backwards, as well as one more and one less from previous units. Because of this background knowledge, the first strategy we use for developing fluency is to connect one more and one less to two more and two less. From this strategy, we will move to using the part-whole relationship, first at the concrete level, and then moving to the representational and abstract levels. We spend about 2 weeks of this unit explicitly teaching and utilizing strategies to build fluency. From there, we will continue to build fluency within our activating strategies with purposefully planned number talks. The unit will then shift to AKS 7. We will have 1 day for some teacher-directed instruction on IOA 7.B, sorting at the representational level. From there, we will shift to IOA 7.C, ask and answer questions, with IOA 7.B embedded. Knowing this is getting close to the end of the year, we are excited to integrate the Georgia DOE learning plan into our pacing. With this learning plan, students will ask questions, collect data, and analyze and interpret the data as they plan an end-of-the-year party. IOAs associated with AKS 3, 6, and 2 are addressed in the provided activating strategies. We have provided a possible summative assessment for Unit 7. The pacing guide then includes a link to the Georgia Department of Education's culminating capstone project. This should be a student-centered learning experience that allows students to demonstrate their mastery and understanding of the content presented in kindergarten. Multiple ideas for projects are included in the DOE learning plan. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Now, let's take a look at possible instructional strategies in action. In Unit 5A, we did a lot of work with students on composing and decomposing numbers within 10. And we did that by having both parts unknown. So before you begin work where you have just one of the add-ins unknown, you may want to go back to having both parts unknown and just working within 5. Remember, this unit is all about building fluency within 5. So if we have this situation, Bailey took 5 counters from the bucket. Some are red and some are yellow. What are different combinations she could have taken? I want my students to use a 5 frame, and I want them to see the pattern that's happening as I'm decomposing the number 5 into red and yellow counters. So I probably would start by modeling for students that maybe Bailey took 5 red counters out and all 5 were red. And then I'm going to go ahead and write that number sentence or that equation next to it. So I would show students that I have 5 red plus 0 yellow equals or is the same as 5. And I can model students counting 1, 2, 3, 4, 5. Hopefully at this point in the year, they'll notice that all the spaces in the 5 frame are full and not have to count that and just automatically know that's 5. Now, as I move on to my next 5 frame, I want students to see a pattern. So this time I'm going to model for students where there are 4 red and 1 yellow. So I'm just going to flip the last one over to yellow. And then I'm going to write my equation. So I have 1, 2, 3, 4 red plus 1 yellow is still the same as 5. One, I want students to notice that I haven't added any counters or taken away any counters. I'm still decomposing the number 5. Okay, the next one, I'm going to continue to show this pattern. So now I want to do 3 red and flip over these two and make them yellow. And I would show students, Okay, I have 3 red plus 2 yellow is the same as 5. So just decomposing 5 into multiple ways. Okay, and I'll continue to do that and model for students. 2 red and 3 yellow. So I have 1, 2 red plus 1, 2, 3 yellow equals 5. Okay, and I'll continue to do that. You also may want to do it the other way. So now that I've done all the combinations this way, then maybe I flip all of these to yellow. We'll do that down here. Flip all of these to yellow and show students, okay, well now I have 0 red plus 1, 2, 3, 4, 5 yellow equals or is the same as 5. Then you can start to have conversations with students about these two equations, 0 plus 5 equals 5, and 5 plus 0 equals 5. And ask students, what do they notice? What do they wonder? Does it matter where we're writing our add-ins? Are we still getting the same sum, the same answer? Those are just questions that you can have, and them seeing the pattern that's happening as you're working with these counters for decomposing the number 5. The very first part of our pacing guide has teachers modeling for students 1 more, 2 more, 1 less, 2 less at the representational level. Students have had a lot of work in units 5A and 5B as they were composing and decomposing numbers within 10 and then adding and subtracting with the whole unknown using concrete manipulatives. So this is a great opportunity since we're just working with 1 more, 2 more, 1 less, 2 less, to begin to show students some representational strategies, including the number line. You may want to go ahead and have printed off for students a pre-labeled number line from 0 to 5. I think this would help students so that they're not having to partition the line equally and label it. We just want them to have practice working on the number line. So I'm going to go ahead and draw my number line from 0 to 5. And then when we're looking at this situation, we want to model for students how to use the number line. That when we move to the right on the number line or we're counting up, that the numbers are getting bigger. And as we move to the left on the number line and we're counting back, the numbers are getting smaller. And to decide when they're going to do that. So in this situation, Kim has 2 fish. She gets 1 more. How many fish does she have now? So the strategy for using a number line is that we're going to start on the number line with what we have. So we know how Kim has 2 fish. So I'm going to start by marking that spot on my number line. And then it says she gets 1 more, or she receives another one. So she's getting another fish. That tells me that she's adding. She's not giving any away. She's not eating any. She's getting another one, and she's getting 1 more. So I will model for students how I can make a jump of 1, and that lands at 3. And then I can go ahead and write the equation for students. Kim had 2 fish, and she is going to add 1 more fish, and now she has 3 fish. So 2 plus 1 equals 3. Although equations are not required for mastery in kindergarten, we do want to expose students to these. You may also want to go ahead and add the number settings for students who need it, that 2 and 1 is the same as 3. So then students can see those 2 parts equals the whole if they need that to represent what these symbols are in the equation. We also will do 2 more. So 1 more, 2 more. So I could have another situation where instead of 1 more, now it says 2 more. And I can model for students how I'm going to make 2 hops on the number line. Instead of just making 1 hop to 3, now I'm making 2 hops to 4. Okay, and I can see that I have landed here. So 2 plus my 2 hops equals 4. We're going to do the same thing for when we're modeling for students 1 less and 2 less. So here I have the situation. There are 4 students playing soccer, 1 student leaves. How many students are playing soccer now? So I'm going to go ahead and draw my number line from 0 to 5. And as I'm thinking through this situation, I'm going to think about what's happening so that students can know whether or not I'm adding or subtracting. I'm not going to use keywords that can begin to form misconceptions. And then they think every time they see certain words, they're going to add or subtract. And then as they progress through the years, that may not be the case depending on what grade level they're in. So in this situation, it says there are 4 students playing soccer, 1 student leaves. How many students are playing soccer? So I want to think about what's happening, kind of create a math movie in my mind. I can see that there are 4 students on the field playing soccer. So I'm going to mark that spot on my number line. And then it says 1 student leaves. So the student is going away. They are not playing soccer anymore. So I know that I am going to be counting backwards or minusing or subtracting 1 student from this soccer game. So I'm going to be hopping backwards on the number line to see that now only 3 students are playing soccer. And I can model for students that I had 4 students playing soccer. We subtracted 1 student, and now there are 3 students playing soccer. I can do the same with 2 less. So 1 less, 2 less. We are first introducing to students part-whole relationships where there's an added unknown. We want to begin at the concrete level. Students have not had experience in units 5A or 5B with added unknown. We were always doing either both parts were unknown or the whole was unknown. So now we're going to kind of look at the add-in unknown, and we want to do this in context so they can understand what's happening in the situation, and then we're going to use concrete manipulatives. And we're only doing this within 5. So if I'm looking at this situation, it says Amara has 5 crayons. 2 are red and the rest are not. How many are not red? So I want students to think about what's happening in this situation by using a 5 frame and some red and yellow counters. This is going to help students visualize or see what's happening. So I know that Amara has 5 crayons. So I'm going to use the red and yellow counters. 1, 2, 3, 4, 5. I don't know part of this problem. I know my whole. I know that there are 5 crayons. Now, as I continue to read the situation, I'm going to model in the 5 frame. So these are Amara's 5 crayons. She's not getting any more crayons and she's not giving any crayons away. The situation says that 2 are red. So I want to go ahead and put in my 5 frame that 2 are red. The rest are not. How many are not red? So as I'm thinking through this situation with students, I know that I have 2 red crayons, or Amara has 2 red crayons. And she also has some yellow crayons. And all together, she has 5 crayons. I can see that in my first sentence. Amara has 5 crayons. 2 are red, which I've modeled that. The rest, so I know because I have 5, I'm going to fill in the rest of this 5 frame, are not red. How many are not red? So now I'm going to move Amara's other crayons down into my 5 frame, and I can show students how many are not red. I see 1, 2, 3. 3 crayons are not red. So I know that 2 plus 3 is the same as 5. You can continue to model this using other numbers within 5. I may tell students that Amara has 4 crayons. Okay, I may change it to 4. I still want to model within the 5 frame. They'll just have to know that one of the parts we're not using. So now these are Amara's 4 crayons. If 2 are red and the rest are not, I'm not adding any more crayons. So now they're just filling in here. So now I can see 2 plus what is the same as 4. 2 plus 2 is the same as 4. Our pacing guide will progress next to part-whole relationships where there is an addend unknown, and we're going to do this at the concrete level. So for this, I can use snap cubes, bears, counters, really any manipulative you have, and then a bowl or a cup. For this situation, I want to model for students that I have some bears, and in this case, we're going to count and see how many bears we have. 1, 2, 3, 4, 5. I have some bears. I'm going to tell students, okay, close your eyes, don't look. I'm going to cover some of the bears. They're going to go inside the cave. And then students will have to look at the bears outside of the cave to determine how many bears are in the cave. So I'm going to ask students, close your eyes, don't look. I'm going to cover some of the bears with a cup or a bowl. Then I'll ask students, okay, how many bears do you see? So they'll uncover their eyes. At first, they'll look to see how many bears we see. 1, 2. And then they have to determine how many bears are inside of the cave or underneath my cup. Now, we know that we started with 5. So in this situation, we are thinking about, we know the sum is 5. So I have 2. And then added to that is my unknown part. And that gives me my total of 5 because I know I started with 5. So some strategies that students might use are counting on. So if we have 2, we'll count on 3, 4, 5. Then they can see how many fingers they have up. 1, 2, 3 to fill in that missing add-in as 3. I can uncover, we can check. 1, 2, 3. Okay, we can do that again. I can push these 5 bears back together. I can show students, okay, I still have 5. Close your eyes. I'm going to put some in the cave. And then ask students to uncover. And again, we'll do the same thing. We'll look at how many bears we can see that are outside of the cave. And then we know that inside of the cave is my unknown number and that I have 5 bears total. Okay, so students may use a counting on strategy. As students become fluent and flexible with these numbers, some may automatically just know it's 4 and tell you, I know 1 and 4 is the same as 5. So we'll uncover, we can check 1, 2, 3, 4. And I know it's 4. Okay, you can continue to do this with other numbers within 5. It doesn't have to just be 5. Maybe for a student in small group, I need to work on the number 3. I can do the same thing. Let's look at how many bears we have. Let's count it. 1, 2, 3. I'm going to ask the student to close their eyes. I'm going to hide some bears under the cup or a bowl, uncover. They're going to look and see, okay, I see 1, 2 bears here. How many bears are in the cave? That's my unknown. Now this time I know that I started with 3 bears. So my total is 3. That's how many bears I have altogether. And what is my missing part? So they may count on. I know I have 2 and 1 more is 3. So there's my 1, and then I can fill in my missing part. As we continue to progress through the pacing guide and we reach representational for building fluency within 5, we want students to be able to use a part whole organizer to help them model their thinking when it's a word problem presented to them, and then use a strategy such as drawing a picture to represent how to solve that problem. So in this situation, it says Caleb and his mom made cookies. Caleb placed 4 cookies on a plate. They ate some, and now there is 1 cookie on the plate. How many cookies did they eat? So before I begin to model a strategy for students, I want students to use a part whole organizer to help represent what's happening in the problem and to organize their thinking to what's happening. Organize where the numbers are going to go so that we don't become number grabbers. So I'm going to think through, I know that Caleb and his mom made cookies. Caleb put 4 cookies on a plate. So I know that's how many cookies we're starting with. That is our whole. So we know that our whole is cookies on the plate. And then it says they ate some. And now there's 1 cookie on the plate. So these are going to be my 2 parts. This is how many they ate. And then this is how many are left on the plate. We do not know how many they ate because it says they ate some. They ate some. We're not sure of that number, but it does tell me that there is 1 cookie left on the plate. So I know there's 1 left on the plate, and I know that to begin with, we had 4 cookies on the plate. This is my unknown number. So I'm going to put a question mark here. This is what we're trying to decide. So if I know my whole and I know one of my parts, I'm trying to find the other part. So I can go ahead and set up an equation for students so that they can see my thinking. I have 4 cookies on the plate, and then we're going to subtract however many we eat, which is our unknown. And now we have 1 left on the plate. So I'm going to model for students using circles. I always tell my students we're not artists in math. We need to be efficient when we are modeling our pictures. So I'm going to model my 4 cookies. 1, 2, 3, 4. I don't know how many cookies they ate, but I do know that there is 1 cookie left on the plate. So I'm going to go ahead and show that this is my 1 cookie left on the plate. Here's my cookie on the plate. I could label that for students. There's my 1 cookie on the plate. What I don't know are how many we ate. Well, now students can see the other part to know that this is how many we ate. And we can count 1, 2, 3. We ate 3 cookies. Another strategy for helping students to be fluent within 5 is through number talks and using dot cards. So if I were to present this image to students, I would ask them, how many dots do you see? And how do you see them? Students are going to start to put these dots together in different ways. Some students may automatically say 5, and they may say, I know it's 5 because it looks like a domino or a die. And they already recognize this formation of dots. Some of the dot cards won't be in the formation that they've already seen it before, but it helps to start with ones that they're familiar with. Other students may say, well, I see it as 3 and 2. They see 3 up here and 2 down here. And then I can record their thinking for them, that 3 and 2 is the same as 5. Another student may say, oh, well, I saw 1 in the middle and then 4 on the outside. So 1 and 4 is the same as 5. Now, you may have students who say they counted 1, 2, 3, 4, 5, but what we want to encourage them is to start to see groupings. Now, you also may have a student that says, I see 2, 1, and 2. And now they're seeing it with 3 add-ins, 2 and 1 and 2 is the same as 5. So using these dot cards is a great way for students to start to put together and become even more fluent within 5. In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.